All right, here we go. Algebra 3, we're going to try to get a little bit more into these trig functions. This is where it gets interesting. So 5.2 is verifying, basically it's verifying trig identities. So basically what they're doing is they're going to give you problems and you're going to have to solve them based on that. So here we go, like for instance, tangent theta squared plus 1 over tangent squared theta equals cosecant squared theta. Now, what you have to do when you're doing these style of problems, when you're doing this a problem of this nature, what you want to do is you want to leave one side the same. So you want to leave like this side, the easiest side, the same, and basically it's going to always be equal to. You're going to bring this problem to verify that this is true, a true statement. So what you have to remember is what are the things that you have learned. So, good example. What have you learned? All right. What can you sub in? What are the different identities that you have learned in this passage, in these different things, to be able to plug in? So, good example. Tangent squared theta plus 1 is going to be able, you can sub in for that as secant squared. Okay, remember, it was down here, there were 3 identities that went with that, so that would be over. What's another way to rewrite tangent squared? Another way to rewrite that is what? So, well, let's leave it tangent squared for a second, all right, for now. So, then we need to plug in and make these in both, put these both in sine cosine. So this one is going to be 1 over cosine squared theta. And this one down here is going to be sine squared, or cosine squared, over sine squared. So that's another way to write those two. Now what do I do? Well, how do I get something out of the basement? Bring it up. So sine squared over cosine squared times cosine squared over sine squared. What does that do? So that cancels out down here, and what does that do up here? That cancels out, and you're left with 1 over sine squared theta. Well, what's another way to rewrite that? Cosecant squared theta. So class, look at the easy version. Is that equal to it? Sure is. So what you're doing is verifying that this side that's the more complex side is really what the other side is. So what you're doing is you're taking one side and you're working with it to get it to be equal to the other side. So let's do another one. This is where it gets really fun, guys. You guys are really going to enjoy this, I have a feeling. Yeah. So 2 secant squared x equals 1 over sine x plus 1 minus 1 over sine x minus 1. So, what do we do? This is the more like non-broke down sign, so leave it that way. We're going to work with this side and try to get it to equal this side, all right? So, first step, how do I get these two to be on the same side? I have to multiply, get a common denominator, right? So sine x minus 1, so sine x minus 1, and this is going to be sine x plus 1, and this is sine x plus 1. So now I can combine them and put them over the same thing. So that's going to be sine x minus 1 minus sine x plus 1, all right, with the parentheses. So you leave the parentheses in so you don't lose your minus sign. Now, what's that do to the bottom? My bottom is going to be sine x minus 1, sine x plus 1. So what do we know? Okay, do the FOIL method. So the bottom's going to FOIL out to be sine squared x minus 1. Okay? Why? Because the middle ones are going to change or cancel out. And then what's the top going to be? Sine x minus sine x is going to be 0. Minus 1 is going to give me a minus 2. Okay? So, this is what we're left with when we do that. Now, what's the next step? Well, remember, we were talking about this right here. What's another way? What's cosine squared x plus sine squared x equals 1? So what's cosine squared x equals sine squared x minus 1. Look familiar? Yeah, so I'm left with minus 2 over cosine squared x. Now what do I do? Oh, I'm sorry, I made a little mistake here, hold on. So, sorry, the other way around. It's really 1 minus sine squared x. So, how do I get this reworded? Well, I put a minus sign through it, right? Which makes it all minus, right? Okay, so that, therefore, it's really minus 2 over, so it gets rid of the minus sign up here, and it's over cosine squared x, which is, wait for it, 2 secant x. Does that look familiar? And basically, it's like writing a proof. And this is why I love this part of the lesson. Okay, because you're writing a proof. Basically, you're keeping one side the same, okay, and you're letting it kind of trickle all the way down, and you're working this problem out as efficiently and as easily as possible using your trig identities and your different functions that you plug in and go from there, okay? All right, so how's that doing? All right, so let's do another 2 problems. We'll do another problem here, and then we'll go from there, okay? All right, here we go. Cotangent x over cosecant x plus 1 equals secant x minus tangent x. All right, so the more complex one is probably going to be this one over here. I mean, they're both pretty complex, but you find one and you work with it. So we'll start with that. Here we go. All right. Oh, I'm sorry. Let's do this one because it has the fraction. So let's work on this side. Let's see if we can get this side to equal this side. So first step, got to get this out of the basement, right? So getting that out of the basement is going to get me what? All right. So when you do that, what do you get? You're left with, up top, cotangent x, cosecant x plus 1, parentheses, all over cosecant squared x minus 1. Okay, because when I do this multiplication, that's going to give me cosecant squared. The 2 middle terms are going to cancel out. 2 middle terms are going to cancel out. All right. I'm sorry, minus 1. Minus 1. So they're going to cancel out. When they do, what's going to happen is you're going to end up with this function. Now, what do we know this function is? If you look back at your Pythagorean inequalities or functions, this is going to become cotangent x. So we're really left with cotangent x, parentheses, cosecant x plus 1, all over cotangent x squared. Well, now what do? Well, first off, I can cancel this. We're left with cosecant x plus 1 over cotangent. Now put them in terms of sine and cosine, and you're left with 1 over sine x plus 1 over cosine over sine. Now what do? I'm sorry, sine over cosine. Sine, cosine. So now what I have to do is I got to bring that both up to the top, right? No, I was right, sorry. Cosine x, sine x. And then when I bring it to the top, it's going to flip it. I'm sorry. So when I bring it to the top, I'm left with multiplying this by sine x, cosine x. Well, when I do that, what happens? I'm left with, so when I do this one times this section, it's going to be 1 over cosine plus sine over cosine. Well, when I do that, I'm left with secant x plus tangent x. Right up here should be minus, all of these are minuses, sorry. And that becomes, and the final product becomes a minus. All right? That is how you would solve that problem. Okay? So it goes back to your kind of your strategy to solving this kind of problem. Okay? Strategy to solving this kind of problem. So let's do another one. And these are all in your book, so if you're listening to this, watching it, that's great. But follow along. We're going to do example 7. Example 7, sine to the fifth power x equals sine x, parentheses, 1 minus 2 cosine squared x plus cosine 4x, parentheses. All right, so here we go. What are we going to do first? So obviously, what's the side that we're going to stay the same? This one. We're going to work on that side over there. So what's a way to work this problem right here? So it's going to be sine x. That's going to stay the same. 1. So think about this. If we FOIL this, you're left with 1 plus cosine squared x, 1 minus cosine squared x, right? Or no, they're both minus, right? Both minus. Okay, so now think back to this equation. Cos squared plus sine squared was 1. What is this? When I subtract cosine squared x minus cosine squared x, you're left with sine x equals 1 minus cosine squared x. So another way to sub in, sine x is sine x squared and sine squared x. Now I just have to add 1, 2, and 2 gives me 5x. Notice that they're equal in the end. So in other words, you just have to verify all you're doing is using the trig functions that you've learned, plugging them in, and using the same mathematical functions that you would use even if they're dealing with x's, y's, or just numbers, okay? It's just now you're using cosine and sines to make it more fun.